There are 3 exponent rules I want you to learn today. The first one is the multiplication rule. The idea being that we have 2 items that are being multiplied together. Key in this understanding is that the 2 items being multiplied together have the same base. That base can be anything you want it to be as long as it's the same as one another. They could be letters, they could be numbers. It wouldn't make any difference as long as they're the same. And if they're the same, that same base comes over into your answer, and you take your exponents, in this case m and n, and you simply add them together. That's all there is to this rule, right? So it's pretty straightforward. An application would be this first question, x to the third times x to the second. We literally just do the same base, 3 plus 2, so we would say x to the fifth, and that's it. That's all there is to it. If we would see one with numbers, 5 times 5 to the third, if you see a number like 5, you can always assume there's an exponent above it. That exponent is a 1, so this is 5, 1 plus 3. So 5 to the fourth. Now we could figure out 5 to the fourth. It's, I think it's 625. So sometimes the answer is going to be expected as a number itself, and they might use the word evaluate. Other times they're going to tell you to leave it in exponential form. And if they want you to leave it in exponential form, just leave it with an exponent. Other times, if the exponents are too big, that means your numeric value will simply be too big, and then teachers are usually okay with just leaving it in exponential form. If you see something with negatives, that doesn't change anything at all. Notice here, same base, 6 and 6, so we have the same base in the answer. Negative 3 plus 5 is just 2. So there's your exponential and your numeric, right? So in this one, either one of these would be acceptable depending on what they're asking for. And the final one, we might fall into a routine where we're just adding the exponents, but notice that these 2 bases are different. 5 is the base in the first, and 6 is the base in the second. And what that means is you can't really do anything with it. So while you can evaluate 5 times 5 times 5 is 125, and 6 times 6 is 36, and you could slam that into a calculator and figure out whatever your answer is. If that's what your teacher wants you to do, that's fine. But if they say something about leaving it in exponential form, you actually just rewrite the problem, and you're done. You don't have to do anything else. You can put the dot in between there if you'd like, or you can leave it out. It doesn't really matter. So that's it, right? Different bases, leave them alone. Now, the second rule is a division rule. The division rule is, well, same in some ways. They're expecting to see the same base. And if you see the same base, then the base shows up in your answer. The only difference here is the exponents m and n are going to be subtracted this time. Your teachers that are showing this to you are surely going to teach you why this happens. That's not my goal in this video. This video is just to show you how it works. So here we go. Same base, x and x. So I'm going to keep the same base in my answer. And the rule says subtract the top minus the bottom exponent. So the top minus the bottom exponent is x to the first, or you could just leave it as x. Those are both the same thing. Next task. What if they're numeric, right? So 5 and 5 mean same base of 5. So we're good there. Let's clean this up a little bit. And we're going to go ahead and subtract your exponents. 10 minus negative 2, so 5 to the 12th. And the last one, you'll notice, again, kind of like I did in the first example, you're going to have different bases. So 6 on one, but 5 on the other. Those are going to be things that cannot follow the rule because they don't have the same base. So once again, you could go ahead and calculate this. 6 times 6 times 6 is 216. 5 times 5 is 25. And you could divide that out and you could figure out what the number is. Or if you're being asked to write it in exponential form, just leave it as 6 to the third over 5 to the second and just move on. For the third and final rule, you'll notice that we have only a single base taken to what appears to be 2 different powers. It's taken to an initial power inside a set of parentheses, and then a second power outside the set of parentheses. And when we see that, we take the 2 exponents and we simply multiply them together. There's really not much to this. So we're going to go ahead and take a look at 2 examples. N to the 5 to the 0, so it's 5 times 0. So we get n to the 0 power. In the next video in the series, you're going to see what to do with that, but for now we leave it alone. And we can have something like 3 to the 2 times 4 power. So 3 to the 8th power. Now, I suppose I could just kind of freeform and make up one more example. What if we had like 5 to the negative 2nd to the 4th power? Now, while we'll get into this in the next video again, just because there's a negative doesn't mean the rule changes. It's just negative 2 times 4. So 5 to the negative 8th power. And once again, in the next video, we're going to do more with this one and this one. But for now, all you need to know is if you see a power to a power, multiply them and you're done.